All right. So I think we are live now. Let me just cross check once and see if it's good to go. Let's see. All right. Yep. I think we're all set. All right. Welcome everyone again to another session on the Scalar community channel. We have been conducting a lot of different sessions on a variety of different topics. Last week we just covered a few topics like cybersecurity and then Web3 projects. Today we have a really great session again. Today we have amongst us Sabyasachi, who is a Google developer expert in machine learning. So if you're not aware of what exactly a GDE is a program by Google where they have experts in various fields, specifically like Google technologies. And Sabyasachi is one of the GDEs for machine learning. And of course, since he's like one of the GDEs for machine learning, today he'll be sort of going over how to build machine learning projects by taking some examples. So we are really happy to have you, Sabyasachi, for coming over and addressing the entire Discord community. So thank you so much for taking out your time.
Thank you very much for this nice introduction, Shiva. And like Shiva has mentioned, I am very much closely associated with Google developer community. I am the Google developer expert in machine learning, also the Google champion innovator in AI/ML domain. So apart from this community activity, I was earlier worked as a data scientist, currently in the academics for teaching in the different universities and colleges. So you see that I am closely associated with this machine learning, deep learning, artificial intelligence, or you may say business analytics in this kind of activity, teaching activity. Is actively researchers on that as well. Also, I am actively researching on IoT domain as well. So before starting today's session, those who are listening to me, I just want to highlight few important things that what are the how you should follow the learning, teaching and learning about machine learning, how should goes on. You see that it may happen that nowadays you are a student in near future, you are planning your career in either in academics for teaching purpose, or may go on research in abroad or Indian top universities, or you may plan of switching your career in industry as well, or in this way you may plan of your career, you may go for the entrepreneurship as well. So there are many options are available, but make sure that if you are planning your career in data science directions, so let me highlight that your prime aspect should be to make your basics very strong. Like you see, as I always say during my talks, that the basics of the statistics and probability should be very, very clear in the statistics direction, descriptive statistics. Okay, for example, central tendency like mean, median, mode, and the dispersion from the central tendency, which you can call as the standard deviation or the variances, which you require to know very, very well. And along with that, the inferential statistics angle. Okay, so the chi-square method, ANOVA, those knowledge you should have very, very clearly. What is p-value, and how can you determine the null hypothesis or the alternative hypothesis depending on the p-value level of significance. These concepts should be very, very clear. And the angle, while discussing on the probability, you require to know very basics related to the probability along with the conditional probability. Bayesian algorithm plays a very, very vital role, because you see all the machine learning algorithms, if you see in the which are based on the Bayesian model or the dynamic Bayesian model. For example, it can be Markov model, hidden Markov model, or even the naive-Bayes algorithm, Bayesian clustering. So this completely based on the Bayesian theorem. So make sure that you are very much comfortable with the conditional probability and Bayesian theorem. So these are the very basics which you require to know along with the central limit theorem. So along with this knowledge, I would suggest that then obviously the linear algebra part comes up, where you should learn about how to compute the eigenvalue, eigenvectors. Okay, so simple things were related to it, like whenever you are going for the singular value decomposition, SVD, or even when you are going to compute the principal component analysis. So in those cases, these things are going to play a very, very vital role there. So please take a note of this, which I have highlighted, like statistics, probability, linear algebra, and the coding portion. Once you comes up here, you see that you can go with R as well. Okay, but there R has a lot of support in statistical computing purpose. Along with that, if you know Python, it is also very good, because you see knowing Python, because Python has a diversified applications in different domain. On the angle of the AI aspects or the data science aspect, if we talk about, you see that all the machine learning and deep learning frameworks are highly Pythonic. Okay, so it will be better that if you know Python, it is going to give you a lot of benefit in your career as well. So, for example, today which will hands-on session which will execute, we will use the MXNet, which is a deep learning framework and highly Pythonic. So you will see that we are using NumPy, Pandas quite frequently, Matplotlib. So this will come up. So once your Python base is very strong, you will be able to do the coding in a large scale. And along with that, if you see, for example, there are a few people who always prefer for the visualization aspect. In those cases, it is a template driven task. You don't need to code the visualization purpose. For example, Power BI, Tableau, those things are there. If you know Tableau in Indian scenario, it becomes easier for you to job a 6-digit salary job in Indian scenario. So there are ample opportunities that whether you can learn those essential skills or not, it depends a lot. So in the right time you have to acquire right skill, and according to your passion you have to choose your career. So you may go for the industry, you may go come to the academics, or you may actively engage yourself in research as well and different R&D organizations. So it's completely upon you, but make sure that your base are very strong. Okay, so such that you can excel in your whatever the career path you may choose, you can excel in that direction. So like today, like I always say that the basics are very important. So today's discussion, we will start from a very basics. Okay, so you will first go through very basics related to the data manipulation, or some interesting concepts to avoid the overfitting scenarios. So I believe that all of you are quite aware of the basic background of the deep learning. So deep learning, although started from the 1980s, the mathematical development have been made, and then also Lilith has been developed in 1988 by Ian LeCun. Although you see that in those era you don't have the support of processing those big amount of the data, so lack of processor power, okay, lack of data storage capacity, because you see deep learning does well when you have the data in order of 10 to the power 5, because machine learning does extremely well until data in order of 10 to the power 4. So activation functions like sigmoid or relu does very well with data in order of 10 to the power 4. But if you go to data in order of 10 to the power 5, you see the performance is not scalable. If you see the curve of the sigmoid function or the tan hyperbolic, somewhere it goes saturated. But you see that if you require to continuous scalability, you require a ramp-like function which has a continuous scalability curve. So there's a reason in deep learning we use activation functions like ReLU. Okay, although ReLU has some problems like, for example, the vanishing gradient problem is there. So you go for the leaky ReLU or parametric ReLU. Those things we will explore today as well. We will draw those things in for example, in the coding session. So I would request that to organizers to kindly take care that whenever I am posting the coding part in the comment box section, and that should be visible to the viewers, as that they can incorporate those codes as their part. Also, I will email my notebooks, Python notebooks, to the organizers, so it will be shared with the participants. So make sure that you are actively participating on it. So I believe that you will enjoy the session. So yeah, we will start with very basics, and then we will explore one live data, I mean one practical data set with those deep learning algorithms, and we'll see the effectiveness and the performances related to that. So for very basics, whenever we are starting, so I will definitely will start with the let me share the screen. We'll start with the data manipulation. How can we do that? Okay, so I believe that the screen will become visible to all of you very soon. Okay, so I think it is now visible to all of you, I guess.
Yeah,
So
I've just
now
added
what
it.
we are going to do, you see, that first of all, I'm doing, I'm just opening Google. Okay, so those who know, please directly open Google Colab. Those who don't know, I'm showing you the step. Okay, so I think the screen is visible. We are opening Google Colab now. Okay, I am clicking on here. So you see now you can click on the new notebook. Once you open it, just click on new notebook. Okay, so now the notebook is in front of you, colab.research.google.com. So you can see some untitled document is showing here, IPYNB. So interactive Python notebook. So I am putting some name like demo, okay, data manipulation, okay. So I am just giving it name as demo DL1, for example. Okay. So now what I will do, I will show you that I will not tamper anything with the original notebook, because this notebook I have written, for example, all the necessary theory, coding part, everything is there in this notebook. So you will get the ample guide from there. So I will just incorporate this coding portion in the notebook section. Okay. For example, here, like you see, First of all, what we are doing, we are starting with the installing MXNet, which is a deep learning framework. Then from MXNet, we are importing NP NumPy and NPX, which is the NumPy extensions, okay, to support all the deep learning activities. So what we are doing, we are installing it. Okay. Meanwhile, what I will do, I will share my code in the comment box section. Okay. So let me post it here. So I am sharing the comment in the private chat section. Okay. So please, I am requesting the organizers to kindly forward as soon as I send the code here. Please forward this code to the participants. Okay, such that they can be able to see that. So this is the way we have completed this particular step of installing all the necessary modules related to the MXNet. Okay, now what we will do, we will proceed further. Okay, so the next step, what we are going to start, that we are generating and tensor, because tensor is a multidimensional array. You see, whenever you have the one-dimensional tensor, it is basically a vector. When you have the two-dimensional tensor, it is basically a matrix. Okay, we will have some number of rows and columns will be there, but more than two dimension, there is no specific name, so we in generally call it as n-dimensional tensor. So basically what we'll do, we want to create the 12 integers. So Python is a zero indexing language, so whenever you do like x equals to np.arrange 12, so it will generate the integer from 0 to 11. Okay, so this particular array we have the value from 0 to 11. Okay, so I am running the same thing here. You see, here you see, once you run this portion of the code, when the installation is done, again you see when you go to the bottom side, here you will find the two options are given there, plus code, plus text. Whenever you want to add some text portion, you want to may add some theory, you want to add some instructions, you can add in the text portion, like I have added all those theoretical part. And coding part, you just click plus code and then you paste the code here. You see run cell button is given there, just click on that, you will run the code successfully. So you can see that all the array elements has been printed there from 0 to 11. It is quite visible there. Okay, so now it may happen that you want to check the shape of the tensor as well. So what I am doing, I am sending the code in your comment box as well. I am requesting the organizers to gradually keep on forwarding all those codes to the participants. Okay, so what we'll do, we will just run this portion of the code here. So I just now want to check the shape, okay, shape and size of the gradually of the those tensors. So if I want to check the shape, for example, so x dot shape, we will do very simple step. So what I am doing here, I am just pasting it here. You see,
Sabsachi,
yes,
actually,
yes.
the team was actually the audience was requesting for the code. Like, can they get access to the code for this file to
Okay,
refer
so I
along?
will definitely after the session I will send it. As
Okay.
of now, you can forward the code to them. Can you? Is it possible? I am sharing the code
Yeah,
in
yeah,
comment
yeah.
box section.
Sure,
So
sure,
please
sure. Not a
forward them,
problem.
and
Okay.
they will get the notebook. I will definitely email you all those notebooks so participants can collect it from you.
All right, all
Okay.
right, all right.
So nothing to worry about it. All the theoretical part is there, coding part is there. So everything you will get the access. Okay. Meanwhile, please try to follow the instructions which I am doing. I am sharing the code in the comment box section. Have requested the organizers to forward you the code. So they will gradually keep on forwarding. So keep on practicing. And this code you can directly, I mean, even this small chunk of code you can directly copy paste from this screen as well, because x dot shape or x dot size is a very simple portion. Okay, and what will happen that in the large code extent, please follow the comment box section. They will keep on forwarding those codes, so you can directly copy paste from there as well. So you see, we are getting the size. Okay, we are getting the shape. You can also get access of the size as well. Okay, how many numbers of the elements are present in the tensor? So you can simply, what you can do, x dot size. If you do, you will get the access of this portion of the code as well. Okay, so what I am doing, I am just sending this portion of the code as well, x dot size, x dot shape. Okay, so you will get the access of everything. Okay, so I believe the organizers are forwarding you gradually one by one. So for example, here also I am running this portion, you see in the screen. Okay, so after this successful run of the code, you will get the size. Okay, 12 elements are comprising in this particular extensor. Now you see what you can do. For example, this is in, like I have mentioned, that this is one dimensional array. So it may happen that you want to form it in a two dimensions. So from vector to from you want to form a matrix. So what will happen? As the size is 12, element number of the elements are 12. So you can easily reshape them with the help of three number of rows and four number of columns. So what we are doing here, we are storing the result x dot reshape. Okay, I'm storing it under the capital X. Okay, now we have the three number of rows and four number of the columns. So you can see once we will run this portion of the code, okay, so you'll be able to see the following output will be generated like I am doing here. Okay, so from 0 to 3 will be in the first row, okay, 4 to 7 in the second row, 8 to 11 in the third row. Okay, so I am also sharing this code in your comment box. Okay, so requesting the organizers to forward it. Okay, so gradually what will happen that you will be able to see that how the outcomes are going on and giving you the alignment of all those array elements. So 0 to 3 in the first row, 4 to 7 in the second row, 8 to 11 in the third row. So you see we have reshaped it, the entire vector in the three rows and with the help of three rows and four columns. Okay, now you see I'm also going to share the next portion of our discussion. Okay, so now what?
Sabyasachi, could
Please tell me.
you, yeah, could you please just zoom in a little bit? Yeah, could you zoom in just a bit?
In Colab, it is not possible to make it zoom. Okay, so
Oh,
it
okay.
is it is it is a standard. I mean standard size which you can view from here actually.
All right, all right.
So you can see there that you can directly forward them the code now. So they will be easily able to see that once with the code each and every line I am just copy pasting in the comment box section. So you can forward them that, so they will be easily view that able to view that. Okay, so now what we will do once we have done this reshaping portion, okay, so next part we are going to will incorporate, that is the basically will be to create the tensor which having all the elements zero. So we can do it like np dot zeros. Here you see, like I have mentioned, that for example if you have the one dimensional vector, so all the inputs will be scalar, which is a zero dimension. For two-dimensional matrix, the elements will be 1D vector. Okay. For any three-dimensional data, there will be the inputs will be all the kind of matrices. Okay. Now here you see that we are creating np.zeros tensor. Okay, two-dimensional sensors which having three rows, four columns, and all the elements are zeros. So if you do like that, so what you have to do np.zeros. Okay, with two rows and three columns. So you can do it like that if you are running these codes. Okay, so you'll be able to see the following kind of the outcome. Okay, so you can see the two matrix elements are all the elements within that are zero within this particular three-dimensional tensor. Okay, in case of the three-dimensional tensor, matrix are the inputs, so you can see that all the elements are zero. So in this way, you can also create the similar kind of thing where the all elements will be one. So how can you do that? So by using np.1. So let me first post this portion of the code here. So you will be able to see the following output. Just a second. Let me reshare the entire. Just let me reshare the entire thing. Just a second. Okay. So now what we are doing basically, once we have done this portion, okay. So np.0 portion is done. Now what we are going to start, we will do the np.1s. Okay. So three number of rows, four number of columns are there. So how can we generate that? We can do it in a similar fashion. So there will be all the elements will be one here. So once you run this portion, you can see all the elements you are getting that will be one. Like np.zeros, we got all the elements as zeros. For np.1s, we will get all the element as one. So let me share the code in the comment box section. Okay, so I am gradually posting all the codes in the private chat section. So you will be able to see that as well. So now what we are going to do next is all about to create the one of the Gaussian distribution. Okay, so from the Gaussian distribution, all of you know that we have the zero mean, standard deviation 1, and it will create in the size of the, whenever your tensor will be in the Gaussian distribution shape. So 3 number of rows, 4 number of the columns. So randomly there will be some randomly selected values. So np.random.normal is going to give you the tensor with the values from the Gaussian distributions. So I am putting it here, so you'll be able to see the following outcome: np.random.normal. So this kind of outcome you'll be able to see, which comprises of 3 rows and 4 columns. So I am sharing it here as well in the comment box section. So you'll be able to see that as well very soon. Now, in the next portion, which we are going to start, that is, you can do the simple arithmetic operations here as well. Okay, if you are defining two in numpy arrays, x and y, so you can do summations, you can do a subtraction operation, multiplication, division, as well as the exponential operation can be there. Okay, so these are very simple steps which can be incorporated here. Okay, so you can see, like, for example, we will go to the next portion of our code. So just click on plus code button, put the codes there. You see all the operations, array related operations: addition, subtraction, multiplication, division, exponentiation. All those operations are implemented quite smoothly. So for example, if you do the addition, 1 plus 2 3, 2 plus 2 4, element wise additions, if you do 4 plus 2 6, 8 plus 2 10. So in this way, the division, multiplication, uh, subtraction, all those things you can do. Okay, so these are the this portion we have done, completed. Now, for example, if you want to do the exponentiation, there is one unitary operator. Unitary operator is also available. Just a second, let me first paste this portion of the code in your comment box. So now I have posted this portion of the code in comment box. Must make sure that line alignments are not will not be proper. So just you have to use little bit of your common sense to align the lines which are present in the code. Then it will run successfully, because after pasting it, you can understand that the line alignments are not remaining perfect in the comment box section. So in the next case, you can see, for example, there will be the unary operators in doing the exponential operation. So in np.exp, once you do, you will be able to generate all the exponential outcome by operating over x. This is the exponential operation what we are doing by using the unary operator like exp. So this kind of outcome you may be able to generate. I am sharing the code in your chat box as well. So you can see there. So now we are moving to the next portion. Okay, like for example, we can do the concatenation operations as well. So how can we do the concatenation operation? Like we have seen that numpy array, you have the elements from 0 to 11. Now we want to reshape it. For example, with the dimensions are given there, like 3 rows, 4 columns. Okay, now once you reshape them, okay, so we already have stored those values under capital X. Already we have incorporated them, and we are generating another y numpy array with having some array elements within it. Now we want to concatenate it. So np.concatenate. So concatenation means merging them together. So once merging the matrices, so there will be row wise merging, column wise merging. Okay, concatenation will happen. Now you see axis 0 indicates in the code in np.concatenate, it is indicating basically the row wise concatenation. And once you are doing axis 1 means column wise concatenation. Okay, so once we do like that, so this kind of following output we will be able to generate. So if you see, for example, 0 1 2 3 is the first row of the first tensor, and the 2 1 4 3 is the first row of the second tensor. So once you merge them together row wise, you see 0 1 2 3 2 1 4 3 is the first row after doing the concatenation operation. So similar way, second row, third row, you will be able to observe. Okay, so let me paste the code, copy paste the code in the comment in the demo notebook. So once I run it, so see, all these codes are quite runnable, and you see, you will be able to see the following kind of the outcome. So concatenation operation you can do in a following manner. Okay, so let me paste the code in the comment box section. So make sure that while executing the code, you are just aligning the lines of the codes in a proper manner. Okay, otherwise it will give you error. So this is the way you can do and proceed further. Okay, so make sure that in this, because you see we are executing it in a Pythonic platform. So you see Colab being the Pythonic platform, indentation error may come up. So unnecessary giving spaces or not giving proper spaces may cause the indentation error. Because other programming languages, when you do the coding, in most of the cases, you see we do the indentation just to make the code look much more stylish, much more elegant. But in Python or any Pythonic framework, whether it is MXNet, TensorFlow, or PyTorch, you can't put unnecessary spacing or do those kind of things, because it will land up with the indentation error. So make sure that you are following it properly. Okay. Now we want to check the elementary wise, element wise matching. Okay. So if x equals to y, if the element wise matching will happen, you will get the output true. Otherwise, we will get the output false. So for example, this case, if we want to check the element wise matching for x, y, like I am pasting the code here, if you see in the demo code notebook. So basically you will be able to see, look, first element of the first tensor 0, first element of the second tensor is 2, so no match, false. Second element of the first tensor in the first row and this second element of the second tensor in the first row is 2, so both are 2. That's the reason it is true. So whenever it will match, element wise matching will happen, output will be true. If there is no matching, output will be false. Okay, so let me send this portion of the code in your comment box as well, so you may try it out by yourself. These are very, very simple examples. Okay, those who already are very strong in Python, they know all those things, but I am doing it for those who are very beginning stage. These are the very basic concepts. Otherwise, you will not be able to understand that how we are dealing with arrays and tensors and for the larger scale solution. So x dot sum will give you the summation of all the elements. For example, I have the elements from 0 to 11. Okay, where the data set size is 12. So 0 plus 1 plus 2 plus 3, in this way, once you keep on adding them up together, so it will give you 66 as an outcome. So that is what we are getting. X dot sum will give you the all the summation output. So what I am doing here, I am just clicking on the plus code button and putting the code here, and once I am running it, x dot sum, it will give you 66. So I am sending you the code in comment box as well. So you see, you will be able to see following kind of outcome. Okay, 66. Okay, so similar way, you can see there are many interesting operations which you may do. Also, for example, like you can deal with like this kind of example as well, like np dot arrange 3. Now once we have 3, now we do Python as a zero indexing language, so the element will be 0 1 2. Now I want to reshape it with the help of the 3 rows and 1 column. Okay, so 3 rows 1 column means what will happen? 0 1 2 will be in a column direction, so it will be a columnar matrix kind of thing. Okay, and now b equals to np dot arrange 2, so element will be 0 1. So I want to reshape it, okay, with 1 row and 2 column. So what will happen? The 0 1, so it will be row matrix basically. So these kind of operations you may do, simple things. Okay, these are very straightforward and simple things which you may incorporate, but these are very conceptual at the beginning stage. Those who are beginners, they have to be very smart enough to tackle with those things, because otherwise it will, you will not be able to understand the large scale problems. Okay, so I have also sent you the code in the comment box section. Make sure you are doing the line alignment properly. Okay, now you see we are doing the summation operation. So a plus b, we are adding to adding up to tensors there. So once you do this kind of operations, so element wise addition will happen and you will be able to see the output. Very simple kind of things, nothing complexity in that. If you see a plus b, so element wise summation output will come up here. Okay, so I am also pasting this code in your comment box section, just check it out there. Okay, so this kind of output you will be able to see. Now let us move to the next example, indexing and slicing. So as you know, the Python is a zero indexing language. So any Pythonic platform will start from zero indexing from the first element. But if you are starting from the last element, you can write it as -1. Okay, so like x minus 1 will give you the last element or last component of your tensor. And if you want to check out the last three elements, for example, 1 2 3, now you see, for example, you want to select the 1 2 3. That means 0 means first element, 1 means second element, and 2 means third element here, because indexing wise. Okay, but whenever you go to 4, okay, you have to access 3, but here upper limit is given as 3 index. So always remember in Python, whenever your upper index is n, for example, so you will be able to execute till n minus 1 element. Okay, so same thing we will do here. Like we want to access the second and third element, so our index should remain 3. Okay, because it will help you to calculate up to second index. So second index value means third element. Okay, zero index means first element, one index means second element. So keep those things in your mind. Okay, these are the very conceptual thing, easy but conceptual thing you may forget. So make sure that you are quite accustomed with all those things, because programming languages wise it varies. Like Python is a zero indexing language, R is a one indexing language. In R, you will always start with one indexing. In Python, you will always start with zero indexing. So language wise, it varies. So be careful about that. Okay. So like these things are simple, but you have to remember the rules and protocols. Okay. I have posted the code in your comment box. You may check it out. Okay. In a similar fashion, we can do it. For example, we can also write it like 1, 2 is 1 and where we are updating. We can also write the elements of a matrix by specifying the indices. So that is how we have specified the indices here. So just a second. Okay, just a second. So once we are specifying the index wise element, like we have specified here 9. Okay, so you see for the first row and the second column, okay, we have given the value 9. Okay, so in the first row and the second column, okay, so the value is 9. So you can see the value has been updated here as 9. So because here you have 0, 1, 2, 3, 4, 5, 6, 7 in the first row and second column, conjoint point of the joint point of the first row and second column, the value was 6. Actually we have replaced the value with 9. We have updated the value. So this kind of operations you may do the updating the value of the kind of the array operations. So I have pasted this portion of the code there. Please check it out. Okay, so this kind of similar kind of operations we may do here also. Like if you see this particular example, what we are doing, 0 to 2 means we will update first row and the second row. Okay, column will remain same. Okay, rest of the things will remain same. First row and second row will be updated with all the elements in the present in the first row, and second row will be 12. Okay, third row will remain same because we are not dealing with the third row, because as I have mentioned that if you are putting upper limit index as n, you will execute up to n minus 1. Okay, so first row and second row element will be updated as 12. So now you see this is a very simple case. Okay, I am just sharing it here, the code window. So if you run it, you will be able to see that all the first rows and second rows have been updated as 12. So similar kind of thing you may incorporate in many cases. Okay, so what I am doing, I am pasting it here. Okay, so you will be able to see the following kind of outcome. Okay, so in a similar way, we can do the saving memory operations we may do. So at first, what we will do, we will start from basic ID before equals to ID y. Now what we will do, y equals to y plus x. Now ID y equals to before. Now in that case, what will happen, that whenever you are starting with y, it is storing in some memory locations. You have that ID of the memory locations. Now once you update them as y equals to y plus x, then you are checking after the updating. Basically once you are updating it, then your y memory location of y will be different. So now if you want to check that id y equals to before, it will give you false. It will give you the result as false because your memory location has been changed, okay, or updated. So this is a very interesting problem, because once your memory location has been updated, you have to make sure that how to do the memory optimization such that you can use the same kind of memory location. So there are tricks are also there. We will be able to learn about that. But let us check the let me post the code first here. Okay, so I have posted the code in our comment box section. So now you see that this portion has been updated. Okay, now the memory location has been updated to a new location. But whenever you will deal with a large amount of the data, where you have the numerous number of the data sets, especially in case of the deep learning, all of you know that we have to deal with the large data sets. So in those cases, updating memory in separate locations will be very memory consuming kind of thing. So can we use the same memory locations for the updating purpose? Can we do that? So same thing can be done. Okay, so there are tricks. So simple tricks are there. For example, just using the indexing sign. And first of all, you start with like this np dot 0 underscore like y. We are creating a similar kind of z, which has a similar pattern like y. Now print idz. So it is the initial memory location it will store. Then you see, once we are writing z equals to x plus y, you see the indexing sign we are keeping there within z, where we are storing the summation value of x plus y. This particular notation will help you to store the value in the same location of the earlier cases. So location before and now will be the same. If we print now, print idz, you see idz in both the cases, the locations are same. Before summation and after summation, locations are same. Memory locations are same. So this is how you can do the memory optimization. So this is a very useful trick which you may follow, because while dealing with the larger data sets, it will the save your memory, okay, from being exhausted. So this kind of things you may follow. Things are easy, but you require to know the tricks. So I am sharing the code in your chat box. Just a second. Already posted it there. So follow this kind of useful tricks. Okay, so things are easy, but you require to know them. Just it. So you see, this kind of operation you can do in this way as well. Even from our basic knowledge of programming, we all know those who started their career with C kind of things from their academic curriculum study or higher school study. So you may see that we often use like x equals to x plus y, or x plus equals to y. So this is a common practice. Both actually implying the same thing. But in Pythonic platform, if you follow these tricks like x plus y, x plus y, okay, x plus equals to y. If you use this kind of sign, just that means it will save your memory locations. It will utilize the same memory locations which was stored earlier for the x value. Okay, so x plus equals to y. Okay, it will store the summation result. It means actually x equals to x plus y, but it means that it will store the earlier location. Okay, it will utilize the memory location for the earlier memory address. So you don't have to do the memory consumption, okay, for the new memory locations. So this kind of useful tricks you may follow. That's the reason id of x equals to before, it will give you true. Now, because your memory location has not been updated, rather it has utilized the earlier memory location. So this kind of useful tricks you may follow, okay, which will give you a lot of insight related to it. Already I pasted it here. You can check it out. So make sure that you are doing the line alignment properly. Okay. So now the conversion to other Python object, you may do it. Okay, a equals to x dot as numpy and b equals to np dot array a. So in both these cases, if you check the type, as dot numpy will give you numpy dot nd array, and whenever you like write like b equals to np dot array a, you are checking the type. It will give you the mxnet. First, it will give you the resource of the framework which you are using, the numpy dot nd array, which is the n-dimensional array. So these are also the things which you require to know, that what are the types you will get for the different little bit of difference in the comment box section. Also, I am sharing it in the your chat window, so you may check it out there. Now it may happen that you want to convert the size1 tensor to a Python scalar. You may do it. So like a equals to in np.array 3.5 value has been given there. So if you print a, it will simply print array 3.5 in the index section. Float of a, it will give you only the floating point value 3.5. Integer int of a, it will only give the integer part. It will chop out the floating point portion. Okay, so this is how you can check out the different other cases as well. So this is also another very simple coding example. So this particular data manipulation section, we have learned about very simple examples related to the coding. So array 3.5, 3.5, when you print float a, okay, integer a, it will only print the integer part. Okay, a dot item will also give you the 3.5 as it is. It was there during the input. So I am sharing the code in your chat box as well. So in this way, you will be able to see the following outcomes. So in a nutshell, we can say the summary. If you see, the main interface to store and manipulate data for deep learning is the tensor, which is an n-dimensional array, and it provides a variety of the functionalities, which includes the mathematical operations, broadcasting, indexing, slicing, memory saving, conversion to other Python objects. You already have learned those things, right? Now we will move to another next notebook, that is the AutoGrad, automatic differentiation. So for that, what we will do, we will open a new notebook. So what I suggest you, all of you, so click on here, file section, go to new notebook, okay, and open a new notebook and give a name like demo dl2. Okay, demo dl2. We are going to explore here simple operations related to the AutoGrad or automatic differentiation. So I am giving the name demo dl2. Okay, this will be the name. So do not worry, all the necessary theory portion has been given there, so nothing to worry about it. So what we will do, first of all, we will all install the necessary modules, whatever there, like mxnet and all those things, and we will generate uh, tensor, okay, with np.arrange 4. You know that it will generate the value, four values, okay, 0, 1, 2, 3. Okay, so first of all, mxnet installation will goes on. I am sharing the same code in your comment box as well. Okay, so once you complete it, then we will proceed to the next portion. So once we have done with all those installation, then the next step, what we will do, we have to do the we have to, first of all, we have to allocate the memory for a tensor's gradient by invoking this attach.grad, x dot attach underscore grad. What it will do, it will allocate some memory for tensor's gradient. Then what the next thing we will do? After we calculate a gradient taken with respect to x, we will be able to access it via grad attributes. Okay, so x dot grad, what it will do? It will initialize all those values. We have first allocated some memory locations for this gradient operation. Then once we have done it, we are storing those values, initializing them as 0. Okay, so x dot grad will give you array elements as 0. Okay, as a starter part. So what we are doing, you see, all the necessary elements have been installed and modules have been installed, and we have generated x np dot arrange, x equals to np dot arrange 4.0, 0 to 0, 1, 2, 3. This is the tensor has been generated. Okay, now what we are doing, we are simply creating the memory locations and initializing them as 0 for the gradient operation. So this is the very basic part what we are doing here. I am also posting the code in your comment box, just check it out. Okay, now in the next part, what we are going to do is that, okay, now we will calculate y. Okay, so how to calculate it? So basically we have seen that y equals to, the basic thing is that here x square was there, 2x square basically. Okay, so once you do the incorporate that part, so np dot x comma x means dot product will happen, so 0, 1, 2, 3 are there. So if you do the dot product and adding them up, so it will give you 14. Now if you multiply them by 2, it will be 14 into 2, it will be 28 as an outcome. That's the reason you can see the output is 28. Okay, so what I am doing, I am just copy pasting it here. So once you run them, so our output is 28. So placing our code inside the AutoGrad.record to scope to build the computational graph. So now we are building the computational graph in a following manner. So I am also sharing it in your comment box so that you can reproduce those results. Okay. So this is how you can reproduce the results. Now you see that we will, next part, what we will do, we will basically now we will do the back propagation, calculation of the back propagation, which is a very, very important part. Now you see that x is a vector of length n, and we are doing the inner product of x and x, which we already have performed. And what we are doing, yielding the scalar output, which we are assigning them at y. Now next we can automatically calculate the gradient of y with respect to each component of x by calling the function for propagation and printing the gradient. So once you do that, so y dot backward, then x dot grad, these operations you do. So what output you will get? 0, 4, 8, 12. So this is the output you will be able to observe once you run the code portion successfully. So that is what we are doing here as well. So you see 0, 4, 8, 12, this kind of outcome you will be able to generate. Now I am sharing the same code in your comment box section as well. You can run it and you will be able to experience the same thing. So this is how you can incorporate this kind of the simple examples. Now you see that basically once why we have the value like x equals to 2 into x transpose into x. That means y equals to 2x square. Now once you do the gradient, take the gradient of it. So what will happen? It will land up with 4x value. So we have to check that whatever the gradient operation we got earlier, x dot grad, can are they matching element wise or not. So to do match them, x dot grad equals to 4x. Okay, it should happen. So element wise, once you do the matching, so in all the cases you should get the output true. If there is a mismatch, then output will be false. So each matching case, element wise matching case, output will be true. So let us check that. So once we do it here, so what are the output you can observe there. So let's just check it out. So once doing the element wise matching operations, you see all the outputs are true basically. Okay, which was not earlier. So x grad should be 4x. Okay, and all the element wise matching will be true after doing the comparisons, and that is how you are getting it. Okay, as expected. Now let us calculate another function of x. So simply in a simple manner, you can do that with autograd dot record y equals to x dot sum. Now y dot backward you may do. So now once you calculate the another functions x dot grad, once you do it, so this will overwrite the newly calculated gradient because you are doing it for a new function. So it will overwrite for the newly calculated gradient. It is quite obvious. So once you calculate it, okay, so your output will be like the following cases you are getting. Array with all the elements as one. Okay, so I am sharing the code in your comment box. Just check it out. Okay, so same kind of things you may be able to observe. Okay, once you do it. Now what we are going to do? Now we will do the backward to non-scalar variables. Okay, so technically, when y is not a scalar, the most natural interpretation of differentiation of a vector y with respect to x is a matrix. Okay, so it is quite understandable. So for higher order and high dimension, okay, for y and x, the differentiation result could be a very higher order tensor. So, however, while these more exotic objects do show up in case of the advanced machine learning or including deep learning, more often when we are calling them as a backward on a vector, so we are trying to calculate the derivatives of the loss function for each constituent of a batch of training examples. So our intention is not only about to calculate the differentiation matrix, but rather some of the all the partial differentiation computed individually for each example in the batch. So if you do like that, so first of all, what is our target? So here we are starting with the with autograd dot record y equals to x square, x into x. Then do the y dot backward. Then you calculate it for x dot grad. So it will give you 0.246. Okay? As simple as that. So let me put it here. So it will give you the 0.246 as it was expected case. Now let me figure it, send it here as well. So let us share the code in your comment box. So you will be able to generate the following kind of outcome. Now detaching of the computation. So here what we are basically doing, here we can detach the y to a new variable u, okay, having the same value as y, but discards any information about how y is computed in the computational graph. Okay, so in other words, the gradient will not follow any backwards through y to x. So thus this kind of the following back propagation function computes the partial derivatives of z equals to y into x, where it is x, where we will make the differentiation with respect to x, and y will be your u will be stated as the constant. Okay, instead of doing the partial differentiation of z equals to x into x into x with respect to x. So now once you do that, so how will you incorporate those things in the coding? So with autograd dot record y equals to x into x. Now u equals to, we are defined as y dot detach function. We are adding it up. So we are making it the independent of the computational graph, which is being used for computing y. Okay. Now z equals to u into x. So z dot backward and x dot grad equals to u. If we do like that, you will be able to, so once you compare these x dot grad operations with u, so all the outputs, all the elements will match with each other. That's the reason if you see all the outcome will be true. So that should be, and that is expected. If you are not getting this kind of outcome, that means there should be something wrong in your logic of code. Okay. So if your logic of the code is correct, then you should get this kind of the output that they should match x dot grad and u which we have done with the help of the detach operation, that should match. So I have posted the code in your comment box. You may check it out there. Okay, so this is the one of the portions which we have discussed now. Since the computation of y was recorded, and we can subsequently invoke the back propagation on y to get the derivative of y equals to x into x with respect to x. So it will give you 2x as an outcome after doing the derivative operation, because y equals to x squared. So after doing the derivation, you will get 2x. So what will be the output here? So y dot backward, then x dot grad. Okay, it will equals to 2x. So after doing the array operations, it will give you the all the elements are matching with each other, and you are getting the output as true. Okay, so after doing the element wise matching, your output will be true in each of the cases. Okay, so here also you can see I am posting the code here, so you can check it out from my comment box as well. So your output will match with each other. Okay, so all the cases you will get true as an outcome. Now, computing the gradient of Python control flow, if you check, so one of the basic benefit of using the auto differentiation, okay, like what you can do, like even if or building the computational graph, basically there you will follow the conditions, looping operations, and arbitrary function calls will be there. So in this following snippet, we have to note that there will be number of iterations of the while loop, or we are executing when the if statement, depending on both the value or the input a. Then we have to see that what kind of outcome we are generating. So first of all, we are defining the function of a, then b equals to a square. Okay, so then we will put some conditional statement with the while loop and if loop will be there. So, and finally you will get the return as c. So if we are incorporating this in the new notebook section, so you will be able to see the following kind of outcome. Okay, so the code will run smoothly without any error. Now I am sharing the code in your comment box section, so you can check it out there. Okay, so once we have done with this particular portion, so let us compute the gradient. So this is the most important step. So np dot random dot normal equals to a. We are storing the result in a. Now what we will do, a dot attach underscore grad with autograd dot record. We will update this function of a value into d, and then with the help of d dot backward, we will compute the back propagation outcome. So if you do like this step, so the following code you will be able to see that if your coding logic is correct, there you will not exhibit any error and it will run smoothly. So this portion of the calculations of the back propagation has been done. Okay. Now the next portion, what you have to do, you have to check that whether our output is correct or not. So to do that, what is the better way? That just a dot grad assign it with d by a. So d by a equals to a dot grad. So once you run that, the array will be true. Array with true outcome will come up. If it was not matching, then outcome would have been false. So that means your process and procedure is perfect. You have run the code with utmost accuracy. Okay, so that is how you are getting the outcome array true. Okay, so this is, we are done with the auto gradient part successfully. Okay, so already posted the code in the comment box, just run it and let me know. So if you see in the overall summary, if we discuss that deep learning frameworks can automate the entire calculation of the derivatives. Okay, and to use it, first attach the gradients to those variables with respect to which you desire to incorporate the partial derivative operation. So we then record the computation of our target value, which can execute its function for back propagation and access the resultant gradient. Okay, so this is how we have done, successfully completed the auto gradient part of deep learning. We have incorporated the coding portion with 100% accuracy, right? All of you have been able to execute the code. So you can understand these coding portions are quite runnable code. You can practice a lot at your home. All the theoretical portion you may see has been added there, okay, with the appropriate section. So we have already started with data manipulation. We have completed that. We have completed the auto gradient part. Now we will discuss about the dropout, okay, which is another important concept of deep learning, because you see that we started with the concepts, like you see whenever the machine learning we have discussed, we all know that the underfitting or the high bias is a great problem in the machine learning scenario. So what we have to do, we too much simplistic algorithmic format may create that kind of problem. So what about doing it in case of the using the deep learning phenomena? So in the deep learning paradigm, the common problem is overfitting. Okay, because you make too much complex model. So in those cases, regularization is one of the way where you can penalize some of the weight from the deep learning framework, and you can make the format look much more simpler. Okay, to execute that particular portion. So dropout plays a very, very significant role there. So you can drop out some of the weights from the network model, and you can make it look much more simpler than the earlier complex cases. So what will happen in that case? You will get the optimum outcome. Why the overfitting happens? This is the very, very important scenario which you have to observe, because you see, you have fitted the training data set perfectly and you are getting very good accuracy there. But while the validation of the data set, when you are incorporating same kind of algorithm there, you are not getting that kind of accuracy. Your algorithm is miserably failing. So that is the scenario where overfitting takes place or the high variance takes place. So in those cases, we always go up with the cases like dropout model. Okay, so let us check one of the simple examples. So first of all, what you have to do, you have to create a new notebook, practice notebook. So we will give the name it as demo dl3. Okay, so let us open a new notebook there, put it demo dl3. Okay, so I am closing the earlier notebooks because it may happen that it may overload or overcrowd your overall network traffic in Colab. So what I am doing, I am just closing the earlier notebooks there. Okay, giving it the name as demo dl3. Demo dl3. Okay, give the name it as demo dl3. Then what you have to do, you have to just use the following example. Like you see the following case, we have seen that x1, x2, x3, x4, these are the input layers. Okay, o1, o2, o3 are the output layers, and among that, within that, you see the hidden layers have been marked here: h1, h2, h3, h4, h5. This is before dropout, and after we have incorporated dropout to reduce the complexity from the network, to remove the overfitting scenario or the high variance scenario. So we have chopped out the h2 and h5, these two nodes. Okay, these two parts. So h1, h3, h4 are the remaining nodes in the hidden layer. So now after incorporating the this kind of the dropout operation, the current structure you can observe. So this is the structure which we are going to discuss, that this is how we are going to incorporate the dropout cases in case of the deep learning scenario. So now first of all, we will incorporate all the necessary download the necessary modules, mxnet, d2l. We will do the download, and then we will put some conditions, that probabilistic conditions, that which we want to incorporate for doing the dropout operation. Okay, so first of all, I am running the code here. You can see this, it will take some time. Meanwhile, I am posting the code in your comment box section, so check it out. Okay, so once you are being able to do this, complete this particular portion. Okay, so we will then start executing the next portion. So I believe that the whole portion of the code has been able to be pasted. One, it is still okay. Just a second, it is still 1.0. Okay, so I have to again post it. Minus dropout has been opted out here. Just a second. So send you the rest portion of the code. Just a second. Okay, so it has been given. Rest of the portion has been also posted there. Okay, so you can check it out from here as well. Now we have already has been executed it. So you see this particular portion is running successfully. Okay, all the necessary version has been installed. Okay, now what we will do, we will basically do execute the next portion. So in the next portion, we are going to discuss, like for example, np.arrange. Okay, reshape 2 comma 8. Okay, so 0 to 15 will be the values. Now 2 comma 8 means two rows will be there, which comprises of the 8 columns. Now we have to fix the dropout probabilities. Okay, so dropout probabilities, we will put some conditions of doing the dropout layer, because you see dropout only will happen in case of the training period. Okay, of the whole network model. So once we go to the output layer, out in case of the, for example, input layer, hidden layer, and the output layer. So we will do the whole dropout operation with the hidden layer during the training operation, because during testing period we will not do any kind of the dropout operation. So probability 0, 0.5, and 1. These three probability operation we are giving there. So condition wise, print dropout layer x comma 0. print dropout layer x comma 0.5, print dropout layer x comma 1. So these are the conditions we have given there. Now you see we are putting it here in your code box. Once you are running it, so you will be able to see following kind of outcome. So 0, 1, 2, 3 up to 15, where you have the dropout 0, that means zero probability. So all the element will be printed. Once you are keeping it as 0.5, 50% dropout. So what will happen? Once has been skipped, dropped out. 2 has been counted in. 3 has been dropped out. 4 has been counted in. 5 has been dropped out. 6 has been counted in. So in this way, all the odd numbers have been dropped out, and the even number has been counted in. And once your dropout is 100%, so see all the outcomes are zero. So this will happen in every cases whenever you will be able to execute the code successfully. So I am sharing the code in your comment box section. So this is how, these are the very simple step, but your concept should be very, very clear, such that you can incorporate them without any headache, without any kind of problem. So now we have defining the number of inputs, outputs, okay, hidden layers, okay, and we have defined all the corresponding w1, w2, w3, or for example b1, b2, b3 corresponding weights and bias, okay, and we have defined combined them under the param values, okay, and for we are running it under the loop for the param with the attached dot grad. So we are basically doing the gradient descent operation. So we are basically initializing their memory locations after calculating all the necessary parameters with weight and bias. Okay, so if your coding portion is correct, it will run smoothly. Now you see I am posting this code in your comment box as well. Make sure, have a look at it. So now what we'll do, we will define the entire model. So first of all, we'll define the dropout. So first of all, you see dropout 1, 0.2, dropout to 0.5. That means 20% and 50% are the dropout cases. Now you see that we are defining the network model. Okay, so in that case, if you see that dropout only will happen in the training of the model, already I've highlighted. So if autograd dot is underscore training, so add a dropout layer after the first fully connected layer. So h1, while defining the h1, we are putting it here, dropout underscore layer function. We are using this particular function h1 comma dropout. Again you see, while defining the h2, so npx relu is an activation function. All of you know, in the deep learning we are going to relu as an activation function. So in case of h1, we already have used it. So np dot we are doing the dot product between x and weight w1 plus we are adding the bias b1. Here in case of h2, again npx dot relu, okay, activation functions we are taking, we are doing the dot product, np dot product between h1 and w2, and we are adding up the bias b2. Then what we are doing, we are defining the autograd function. So where we are adding the dropout layer h2 comma dropout 2, and then returning np dot, okay, where we are doing the dot product between h2 comma w3, and we are adding the bias b3. So this is the common structure for the new overall the perceptron concept. Those who are familiar with it, this is a very common structure. So that is we have followed. Now what I am doing, I am pasting this portion of the code in my comment box and running it. So it is running smoothly. That means there is no error. You can also check out in your case as well. I am sending it in your comment box as well. So once we have completed this particular portion, okay, so now we will do the training and testing part. So this is quite similar to the training and testing of the multi-layer perceptron concept, what we have learned earlier. So you see that we have defined all the necessary ingredients like the training iteration, test iterations, okay, overall loss. So loss calculations has been done using the softmax cross entropy loss function. Now you see, once we are putting it here, this portion of the code, so you'll be able to see the following kind of the outcome will be generated. So it will do the all the necessary steps, and you can check this kind of the output will come up, because it will take some time to show you the output. So I am explaining it here. You see that epochs has been defined as 10, okay, learning rate has been defined as 0.5, and the batch size is 256. Now you see, once the number of epochs are being increased, this blue, look at this blue line, training loss is being reduced. So that is the main objective, that how can we reduce the training loss that has been reduced, you can see. And this green dotted line, or this particular pink dotted line, if you see, these are indicating the training accuracy and testing accuracy, which are quite high, almost nearby 95%. So that means your model is doing quite good. Okay, so this is the necessary, this is the basic this desired outcome which we are getting. And now you see, this code is generating the graph gradually. I am posting the same code in your comment box, so you can follow them and you can run it successfully. So we'll be able to generate the following kind of output here. Okay, so meanwhile it is running, let me go to the next portion, okay, of our discussion. So once we have completed it, then what we'll do, we will basically will now focus on the high level API. So all we need to add is the dropout layer after each of the fully connected layer. Okay, so passing and in the dropout probability as the only argument as its overall constructor. So during the training, the dropout layer will randomly drop out all the outputs of the previous layer, okay, and according to the specified dropout probability which we have defined earlier, okay, for dropout 1 and dropout 2 values, 0.2 20% and 0.5 for the 50%. Okay, so now once we have completed that particular step, so when not in case of the training mode, but the dropout layer simply will process the data through during testing. So we are first of all defining this sequential layer, you can see, which we will assign it as n. The net, now net dot add, we will put the dense layer 256 and activation function relu. Okay, and again nn dot dropout 1, nn dot dense 256 activation relu. Then finally nn dot dropout 2, nn dot dense 10. So now we are initializing it net dot initialize init dot normal, where the sigma value has been given there as 0.01. Okay, so this portion we have incorporated here. Okay, so now what I will do, I will just show it. Look, this whole graph has been generated, the similar kind of graph which we have observed in our case as well. Now first of all we will define this, all the sequential uh, layer along with the corresponding dropout percentages. Okay, now what we will do, we will put the next, execute the next portion. Okay, training and testing model will be done there. So simply, okay, gluon.trainer, you will put all the necessary parameters, stochastic gradient descent, learning rate, all the information has been given there. So after incorporating that particular step, okay, you will be able to generate the following output. Okay, so meanwhile it is running the code here. I am sending you this portion of the code in your comment box section. Okay, so you can run, you will be able to run it by yourself. So meanwhile it is running, you will be able, let me explain it from my original notebook. So this kind of output you'll be able to see. Once the number of the epochs are increasing, we can observe the drop in the training loss or in overall. Okay, so the desired thing you can observe, and this pink dotted line is the training accuracy and the green dotted line is the test accuracy. So in that case we can see the accuracy level is well enough to achieve nearby 90%. Okay, so in overall summary, if we see that beyond controlling the number of the dimensions or the size of the, or the overall size of the weight vector, dropout is yet another tool to avoid the overfitting scenario. Often they may be used jointly, and it replaces the activation h with a random variable with expected value h, and dropout is only used during the training of the entire network. Okay, so this is how we have seen the following case. You can see this graph is being generated, so it will take some time to generate it in a fully manner. So I believe that this portion is quite now easier for you to understand. So we have completed data manipulation, auto grading, and automatic differentiating, and the dropout. Okay, now we will move to the multi-layer perceptron portion. So this is a very important scenario for the multi-layer perceptron. So to execute this multi-layer perceptron, I am requesting you to create another notebook and give the name as demo dl4. Okay, so your notebook name will be demo dl4. Demo dl4. Okay, so now we have to see that this kind of the multi-layer perceptron concept, whenever you will have the input layer, you will have the output layer. Okay, and meanwhile is the hidden layer will be much more in a complicated manner because it's a dense network, not a shallow network. So if we see the overall scenario, that what is the multi-layer perceptron concept, because MLPs add one or more fully connected hidden layer. You can see in the summary section of this particular notebook, you will be able to see all the required things has been added up there. Like commonly used activation function include ReLU or the sigmoid or the tan hyperbolic, or MLP adds. MLP means multi-layer perceptron, adds one or more fully connected layers, okay, along with the hidden layers between output and input layer, and it can transform the output of the hidden layer by the activation function. So we will incorporate all those activation functions one by one. So in first of all, we have to install all the MXNet D2L, okay, all the necessary setups, NumPy and NumPy extension NPX we have to do. So here we are installing all the necessary setups here, okay. So meanwhile, I am also sharing the code in your comment box such that you will be able to incorporate this portion as well, okay. So it will take some time to execute. You see now from the earlier notebook, you see all the graphs has been generated successfully, okay. So these all are the successful. You can run those codes quite successfully if you have understood it very well, because there is nothing in it. Now first of all, we'll start with the ReLU function. Like I told you, the ReLU or rectifier linear unit is an important function in terms of the activation aspect. So the basically it is shown as the ReLU of x equals to max of x comma 0. So what will happen, it will have a ramp like function, okay. So what we'll do, we will first execute to generate the plot of the ReLU. Let us see that how we can generate the plot of ReLU function. So you can see the successful installation has been happened. Now once you put it here, so you will be able to see the following output, okay. So basically, you see that x below x or the negative value of x, the ReLU will not exist. Okay, ReLU will only exist when you have the value greater than x greater than equal to 0. So you can see that below x it is 0. It is existing only for x greater than 0. So this kind of the ramp-like function you can see. So that is the beauty of ReLU function, because it has a ramp-like function. There's a reason deep learning algorithms are performance-wise scalable. You can achieve the accuracy even nearby 100% to 100%, where machine learning performance gets saturated because of the saturation nature of the sigmoid or the tan hyperbolic function. If you see the curves, these are quite easier to understanding purpose. So I am pasting the code here in your notebook, in your comment box as well. Please check it out there. So now we have generated the ReLU function successfully. Now what you will do, you will do the differentiation of the ReLU function. So once you do the differentiation of the ramp-like function, what kind of function you get? It will be the step function, right? So this is a very common question in the GATE exam. Those students who are, if there are students from the electronics and communication engineering background or the electrical engineering background, they often face this kind of question in GATE exam, that what will be the differentiation of the ReLU function, this ramp-like function. So you get the step function as an outcome, or if you do the integration of a step function, okay, so you will get back the ramp-like function as an outcome, because ReLU function has a ramp-like structure, okay, so which basically gives you the continuous scalability. Okay, that's the reason you have to understand that every mathematical development, there is a philosophy behind that, and that kind of philosophy comes up from this kind of the curvature. Okay, so you have to understand that whenever you have this kind of ramp like structure, it is going to give you the continuous scalability factor. So that's the reason the philosophy behind the superhuman activity, or which is the main in which play the pivotal role of generating this kind of the deep learning concept, was the main reason behind that. So once you will be able to run it successfully, you can see the step-like function is being generated. Okay, so doing the derivation over ReLU will give you the step-like function. Okay, step function or unit step function. So let me share the code in your comment box as well. You will be able to generate it as well. So you have to have a very basic understanding of your mathematics could be strong, such that you can understand this kind of scenario. Now you see, like I told you, that because the negative value of the x, you will not get any kind of the output. So x equal to 0, you will face the vanishing gradient problem or the vanishing moment problem in case of the ReLU or linear rectifier linear unit. So in that particular reason, we always go for the leaky ReLU, okay, or the parametric ReLU. Okay, so parametric ReLU is being denoted as p ReLU of x, where you will get maximum of 0 comma x plus alpha mean of 0 comma x. Okay, so this kind of output you will be able to generate. So make sure that parametric ReLU we are studying very very carefully, because this kind of question often being asked. If you are appearing for an interviews related to deep learning expertization, these questions are being asked very often. That what is the shortcomings of ReLU? Okay, vanishing gradient problem or the vanishing moment problem. Okay, so that's the reason we often go with the parametric ReLU or leaky ReLU kind of approach. In case of the parametric ReLU, it will be max 0 comma x plus alpha min of 0 comma x will be the basically the structure in general, because we add some portion that such that we can avoid that 0 0 phenomena, because you see it is undefined case. Okay, because you can't do the derivative in that particular scenario, where either they will vanish or they will just let the argument through. So that's the reason you have to put some values, like you see for x less than equals to 0. In case of the leaky value, we put some very small amount of the value, 0.001x, such that we can just to avoid this kind of the vanishing moment problem. Okay, so now we can see the sigmoid function curve as well. Now we know that the sigmoid function, if you have idea about the logistic regression, the equation structure is quite same. So sigmoid of x equals to 1 by 1 plus exponential of minus x. Okay, when you have the overall range minus infinity to plus infinity. Now if you see that, if you are putting the value there with autograd dot record, okay, y equals to npx dot sigmoid of x. Now once you do the plotting, so you'll be able to successfully generate this kind of the sigmoid function curve. Okay, so this is one of the premier activation function is being used in machine learning. Now you see this particular graph structure. Okay, you will start gradually, scalability will start enhancing, and then after certain time the scalability will be saturated. That's the reason I'm saying the same problem will happen with the tan hyperbolic as well. That's the reason tan hyperbolic or sigmoid is not being used in case of the deep learning. And the first deep learning architecture, which has been developed in 1988, it has the same problem, because they used sigmoid as their activation function, because they don't have the options as well. Nowadays we can talk about performance wise scalability, because nvidia in 2012 they came up with gpu, or google in 2016 they came up with tpu. So you have the support of gpu and tpu respectively for 2012 and 16 onwards. But earlier it was not possible. That's the reason people thought about this kind of mathematical structure in their mind, but practical deployment was not possible until or unless you have the high processor power support. So it's not only about the algorithmic development or the mathematical development. You require the hardware support as well for the to store the data, to process the data. Okay, so that's the reason gpu and tpu made the miracle in the era of the computations. Okay, so if we paste this particular portion of the code in the comment box, and if you can run them successfully, you will be able to generate the you will be able to generate this kind of the following graph, like the sigmoid function. Now if we are doing the derivative over this kind of sigmoid function, like ddx of sigmoid of x, if you do like that, so what will happen, you will be able to generate sigmoid of x 1 minus sigmoid of x. Okay, so this will give you the Gaussian like structure, Gaussian like curve you will be able to generate. Okay, so let me show you that how can you generate this kind of the curve. So I am running it in my demo notebook. Okay, so you'll be able to generate this following kind of curve. Okay, which is a grad of sigmoid function curve, which is a Gaussian like structure you will be able to see. I am sharing the code in your comment box as well. Okay, make sure that you are able to run it. Okay, so this kind of the output you will be able to generate here. Okay, now for example tan hyperbolic has the same type of the problem, because general structure is tan hyperbolic of x 1 minus x exponential over minus 2x divided by 1 plus exponential of minus 2x. Now y-axis ranges between minus 1 to plus 1. Unlike the sigmoid, we have put the y-axis range between 0 and 1. In case of the tan hyperbolic, we can put the range between minus 1 to plus 1. Now you see, if we are doing the same kind of algorithmic operations over here, so in that case you can see similar structures will be generated. Only the y-axis limit will be between minus 1 to plus 1 range, so you will be able to see some negative swing as well. So in that case, if you see this overall structure here also, you can see same type of the problem will happen. It is not performance wise scalable. So if you are getting the similar kind of structure, and if you do the differentiation over it, you will again get some kind of the Gaussian type structure. Okay, so make sure that you are being able to run it properly. I am sharing the code here for the tan hyperbolic. Okay, generate the function and let me know. And now you see, once we do it, ddx over 10 hyperbolic of x, if you do the derivative, the output will be 1 minus 10 hyperbolic square x. Okay, so if you get like this kind of structure, so that will also follow a Gaussian kind of curve. So that's the reason I'm saying that whether it is tan hyperbolic or whether it is sigmoid, none of them are performance-wise scalable. These are good for a machine learning scenario, but whenever you go to deep learning, you must have to use ReLU. Okay, so you see this type of the curve is being generated. If you can run this code successfully, you will be able to see following type of curve. Okay, so see this kind of structure you will be able to generate. Okay, so this portion we have discussed this the multi-layer perceptron in a wide manner. So multi-layer perceptron basically adds one or multiple fully connected hidden layers between output and input layers, and also can transform the output of the hidden layer via an activation function. And commonly used activation functions, which include the ReLU function, are there, sigmoid function, tan hyperbolic, all those things are there. So we have talked about the data manipulation, dropout, auto differentiation, or the cases like this kind of the multi-layer perceptron. Now we are going to talk about one of the simple examples that is we are going to incorporate. Okay, the house pricing cases on Kaggle. Now all of you know that Kaggle is a very good platform for doing the data science related competitions. You may take a part of it. So one of the data sets which are we going to use, that is the Kaggle house pricing data sets. Okay, so all the details related to how to download it, how to access it. Okay, every details have been given there in the text, so nothing to worry about it. I will email that to your organizers, so they will share with the participants. So nothing to worry about that. So meanwhile, just we will try to focus on, rather than on the coding part. Okay, that what are the modules you require to install and all. So I am requesting all of you to create a new notebook, give a name that demo DL5. Okay, put the name as demo DL5. So the name will be demo DL5, right? So give it there, demo DL5, and then just paste the code there and make sure that if your code is perfect, it will be able to import all the necessary modules which you require to run this portion of the code. So I have also pasted it here as well. You can check out in your comment box section. Okay, so once we are done with that particular part, okay, now what will be the next part? We have to define this particular download function. Okay, so you have to define the name, you have to define the cache directory with the providing proper path. Okay, so once you put those things there, the data sets will be able to download in a proper manner, because you have to connect with Kaggle, you have to download the data sets. So this is the following code, just follow it, you will be able to run it successfully. So I am sharing the code here. Okay, now what will be the next step? In the next step, we have to go for, because we also have implemented two additional utility function, that is to why how to download it. But we have to be very careful that we have to keep it in two aspects in mind: one about downloading it and then extracting the zip or the tar file. Okay, and the other to download the all the data sets, okay, which are necessary. So basically what I am doing, I am taking this portion, I am putting it here as well. Okay, just to show you that how to extract these downloaded files. Okay, downloaded zip files or tar files. Also I am putting it here as well in the comment box section, so you can download it from here as well. Okay, so once you have done it, then the next step will be basically to check that, for example, in the pandas, we can install the mxnet. Okay, you can install the d2l already. Pandas, in if you are using Google Colab, pandas are already installed there. Okay, so you don't have to install in uh, install those cases here. But if you are using in case of the using the Anaconda or all those installed platforms, if you are not installed there in pandas, you may have to install it. So in that cases, we have seen that mxnet, pandas, and the d2l, these are the main modules which you require to run this portion of the code. Okay, because we are gradually now going to get access of the dataset which we have extracted after downloading from the zip file. Okay, now it will be in the CSV file. So data underscore hub, we will access all those CSV files after downloading it from the Kaggle. Okay, so there also you see these pandas are going to play a very vital role. That's the reason we have we have incorporated them here. So make sure that you are downloading it here. So I am sharing the code here. Okay, so make sure that you are using it properly. Then what will be the next step? The next step we have to see that we have used pandas to download two CSV files. Okay, for example, training and test data respectively. Now what we have to do, train underscore data, okay, pd dot read underscore CSV download, okay, train underscore house underscore kaggle underscore house underscore train, and under the test data which we have defined pd dot read underscore CSV kaggle underscore house underscore rent for the test dataset purpose. So now what we will do, we will do the training and testing. Okay, so we are running this portion of the code here. I am also sharing the code in your comment box, so please have a look at it. Now once we have completed this portion, okay, so we can see that this particular training dataset having 1460 examples with 80 features, one label, and the test data with 1459 examples and 80 features. So what we have to do, we have to print test underscore data dot shape and train underscore data dot shape. Once you do that, you will be able to figure out the following outcome which you are getting from here. So this portion of the code, once you print it, so you will be able to see the following dimensions or the shapes of the datasets which have been used for the training and testing purpose. Okay, so once we are done with it, it may able that you want to have a look on the two portion of the datasets. Okay, so basically what we have to do, we want to look at the first four and last two features. So accordingly we have written the code and we are putting it here. So let us check what kind of output we will be able to generate. So I am also sharing the code in your comment box, so check it out there. Okay, so you will be able to see, for example, I corresponding IDs are given there, MS subclass, MS zoning, okay, lot frontage, cell type, okay, cell condition, cell pricing, all those informations are given there within the dataset. So it is always better to look at the dataset. Now you see which particular feature are going to give some of the information related to the classification. That portion we have to basically, that particular column we have to chop out from the dataset. Otherwise, it will it will add up some kind of the biasness in your result. So once we form this kind of the all underscore features pd.concat, okay, under that we define the data train underscore data dot ilog. You put the proper details indexing there, then you complete the indexing for the test underscore data ilog. So once your proper indexing has been completed, make sure that you are running it in successfully in your Colab. Then you proceed to the next portion. So before going that, also let me share the code portion in your comment box as well. So we have completed this particular part. Now we are going for the data processing. Now while going to data processing, make sure that you have standardized the data set. So standardization or the normalization, we generally do data minus mean divided by standard deviation. Okay, so once you do it, your standardization of the data sets are done. So now we will follow the same thing in under the coding. First we will do the standardization, then we will remove all the missing values. Okay, in the last line you see all underscore features numerical underscore features, all underscore features numerical underscore features dot fill na equals to 0. So if there are any missing values after the standardization step, those will be removed. So do not forget to do the standardization. Data minus mean divided by standard deviation is the basic step which you should follow. Okay, so this you can do. I have sent the code in your comment box. So once we have been able to incorporate that part, then what you have to do, you have to check, for example, that one hot encoding you have been able to do correctly or not. So in that case, after doing that particular step, we have kept the argument or the parameter dummy underscore n equals to true. Okay, so now you check it out here. Okay, so basically the one hot encoding step has been incorporated in a perfect manner. Now what we have to do, we have completed this particular step. Okay, deal with the discrete values whenever your data is dealing with the discrete values. So next case, what we have to do, we have to extract the numpy format from the pandas format, and we have to convert it into the tensor. That is a very vital step, because you can see the conversion increases the number of features from 79 to 331. Okay, so finally Via the values attributes, we can extract the NumPy format into the pandas format and convert it into the tensor for representing the training results. Okay, so if you do like this, okay, so I am copy pasting it in your comment box, in your this demo portal, okay, demo code running portal, as well as in your comment box section as well. So try it out. So basically, this is also running successfully. So you can see once we have completed this particular step, the conversion has been done from the the NumPy format, from the pandas format to the tensor format. Now the next thing will be to calculate the training portion. So we will define the loss, and we will also define the get underscore net function. Okay, and once we have done this particular portion successfully, so we will see the next, we will proceed for the next portion. But before that, I believe that all of you will be able to run till that what we I have been able to incorporate it here. Okay, to return net, we have completed this particular portion. Now, in the next case, we will have to figure out that what will be the raw log root mean square error value. So next case, what we are doing, we are calculating the log root mean square value. So the formula is square root 1 by n summation of I equals to n log yi minus log yi cap whole square. Okay, so this is how you can calculate the log root mean square error value. So once you are being able to calculate that, just make sure that you have defined all the arguments and the parameters in a proper manner. Okay, so let me post this code here. Okay, so I think you will be able to run it successfully. So now once we have completed this particular step, so we have to define the Adam parameter. Okay, so here what we'll do, once we want to run to training, once you want to execute the training program, so under this definition of the training function, you see net train features, okay, train levels, test features, test levels, number of epochs, learning rates, weight decay, batch size, all those things we have to define as a parameter of that particular function. Once your definition is, once you define them perfectly, okay, we'll be able to execute this portion of the code in a proper manner. So let me share it in your, just a second, in your comment box as well. Yes, so after completing this particular step, then what we will do, we will proceed to the next portion. Okay, so now this is the k-fold cross validation. So k-fold cross validation, we will define one particular function under it, get underscore k-fold underscore data. So ki and xy, these two values you will have to give there. Then define fold size, okay, like x dot save 0 divided by k, and also these definitions, like first define in x underscore train and y underscore train as none, and then run the for loop accordingly as per the fold size. So fold size is going to play a very vital role here. So there will be for loop and if and else loop will be there. So you have to define the conditions appropriately under it. Okay, so once you can run this portion of the code, let me also share it in your comment box as well. So this is how you can define this particular portion. Okay, so once we have completed this particular portion, now the next section will be the a training and the verification error, okay, which you require to make them average as per the return. So you can train k times, you can, in the k-fold cross validation, already we know from the basic definitions of the cross validation. So this we have to define under while defining the k-fold cross validation function. Under that you have to mention all those parameters carefully, like k will be there, obviously x underscore train, y underscore train, number of the epochs as n underscore epochs, learning rates, weight decay, and batch size. Once you define them perfectly, first of all, train underscore sum and valid underscore sum, you define them, you initialize them as 0, then run the for loop over them, and finally you will be able to return the train underscore 1 underscore sum divided by k and valid underscore 1 underscore sum divided by k. So this kind of outcome you will be able to generate. So once you define this particular portion, make sure that you are being able to run this particular function definition in a perfect way. So I am also sharing this in your comment box section as well. So we have been able to incorporate this particular portion quite correctly. Now you see the model selection we have to do. So in that case, you have to, again, you have to define all those things. K, number of epochs, learning rate, weight, decay, batch size. So K will be at 5, number of epochs will be 100, learning rate will be 5, okay, weight decay 0, and the batch size is 64. So accordingly, once you do it, so let us see after incorporating this particular portion of the code. So following output you will be able to generate. Okay, so once we are running it, meanwhile, let me share it in your comment box as well. So once we are doing it, you see that, just a second, one. Uh, so it is running, the code is running here. Meanwhile, let me explain from the original notebook. So you can see this kind of the output you'll be able to generate. The y-axis is basically root mean square error. Okay, and the epochs is in the x-axis. So with the number of the epochs, you see we have defined the epoch as 100. So once you were gradually achieving towards 100, your root mean square error is gradually decreasing for the training and the validation, both the cases. Okay, so this is how you can reduce with the number of the root mean square error with the number of the epochs. Okay, so that we have observed earlier cases also. Here also we are observing the same thing. Now the submitting the predictions on Kaggle, if you want to do that. So now we know that a good choice of the hyperparameter should be might as well use for the all data to train it. For example, rather than just putting it like 1 minus 1 divided by k of the data that are used in cross validation slices. So the data model, what we will use, we have obtained so far. Okay, we can obtain to be applied it over test data set, and saving the predictions in a CSV file will simplify the loading the results to Kaggle. So if you want to do that, so first of all, define train and underscore pred function. Okay, so under that, make sure to mention all the important parameters: train underscore features, test underscore features, train underscore level, test underscore data, number of epoch, learning rate, weight, decay, and batch size. So make sure that you are defining those in a proper manner. And finally, whenever you are doing it, these two lines are very, very important. That submission equals to PD underscore concatenation is very, very important. Test underscore data ID, comma, test underscore sales price, comma, axis equals to one. Axis ones mean you are denoting the column. Okay. And then finally, submission to underscore CSV, keep the file name as submission underscore CSV, because you want to submit into the Kaggle, so you have to submit in CSV file. So index equals to false, keep the index equals to false. Okay, so once you do that, then just in the beneath of it, this particular plot, just run this portion of the code. Also, I am sharing the code in your comment box section. Okay, so make sure that you are being able to run it. Then once you are done with that particular portion, okay, so what we'll do next, we have to see that once particularly if we do for example one checking like to see whether the predictions on the test set resembles those of the k-fold cross validation process. So if we do, it is time to upload to the Kaggle. So the following code will generate this particular file called submission.csv. So let us do that. Let us generate that. Okay, so what we are doing, we are basically put it here and try to check out that what kind of the output it will give. So if you run it, meanwhile I am also sharing this portion here as well. Okay, already in the comment box I have shared the code. So it is running now. So finally you will be able to see this kind of the output, which I am just a second, which I am showing it here. So again, you see with the epoch, you can see there is fine decrement in the log root mean square error value. Okay, so next we can submit our prediction on Kaggle and see their comparisons with the actual house pricing and that on the test data set. So tests are quite simple. So what are the steps you have to follow? First of all, log into Kaggle website. Okay, everything is written there in the notebook. Don't worry about it. Okay, so make sure that you have got the confidence by running those codes successfully. You have seen that these all are runnable code. So try to understand step by step what we are doing and read those written content, theoretical content from here. So it will give you a lot of confidence while incorporating it for your own cases. So we have incorporated the Kaggle house pricing data sets by using deep learning algorithm, and we have been able to achieve the accuracy nearby 100%, nearby 90, more than 95% to nearby 100%. So log into it into the Kaggle website, visit the house price prediction competition page. Then the second step will be click the submission, submit predictions or let's submit button. Okay, as of the writing, the button is located on the right. Okay, then click the upload submission file button in the dash box at the bottom of the page and select the prediction file you wish to upload. Then what you have to do, make the submit, click the make submission button at the bottom of the page of to view the overall result. Okay, now in the summary, what we have observed, these are the steps which you will follow, you will get the necessary outcome. Okay, now you see, for example, in this case also, it is almost the execution is done. You see, we have got the output, and you see train log root mean square error is 0.162399. Okay, so, in a summary, we can say that the real data often contain a mix of the different data types, which is required to be pre-processed first. And once we have done the pre-processed, the risk scaling of the real data set, okay, like the standardization or the normalization, which we are talking about, to zero mean and unit variance is a good default. Okay, by replacing the missing values with their mean values is another important practice. So, once you get the data set in the pre-processing step, data minus mean divided by standard deviation, you have to follow. Then you have to check for the missing values. So missing values can be replaced with the help of the mean values. So transforming the categorical features into the indicator features also allow us to treat them like one hot vectors. Okay, and also we can use the fold cross validation to select the model and adjust the hyperparameters. And finally, the logarithms are quite useful for relative errors purpose. Okay, so you can remove the root mean square error. Okay, you can try to reduce the root mean square error as much as you can. Okay, for any optimum outcome of the model. So that's all about today's discussion. We have discussed on data manipulation, followed by dropout concept, a multi-layer perceptron concept. We have discussed auto differentiation. We also have discussed how to utilize you can take part of the Kaggle dataset competition, or you can download the Kaggle dataset. You can you run your algorithm. You can upload the outcome with the help of CSV file to that. So a real practical world dataset we have explored. That is the Boston house pricing dataset, and we have made all the necessary prediction related stuffs there. So I am making the stop screen sharing. Okay, so if you have any doubt or queries, please feel free to ask me. Okay, and don't worry, all those I will share this pipe and Python notebook to your organizers, so they will share with all of you. Make sure that it's not only about running the code successfully. Make sure that you are learning the steps with the proper manner. Okay, and you are going through the theoretical details there, because every details related to the theory is been mentioned there. Okay, due to lack of time, it's not always possible to explain the everything. Okay, but coding portion we have completed. We have discussed all the nitty-gritty portions related to the algorithm and coding part. We have made a brief overview on the theory. So make sure that you are going through the theory part as well. I have written all the details related to the equations, and all the details are there. Please feel free to go through them. And if you require any help from me, I am sharing my email ID there in the chat box. So email me regarding any discussions or any confusions. Okay, so go through them and feel free to contact me as well. So this is my mail ID. I will request the organizers to share it with you or with all of you. Also, with the request of the students, I recently started to write the Medium articles, so you can also follow them as well. So basically, I am trying to give them some guidances related to in which pathway they should follow in the data science domain to make a successful career in the data science related thing stuff. So I am sharing my Medium article link there. Okay, so you can follow me in Medium as well. Also, I created a separate GitHub repository just for the students. Okay, so where I am gradually uploading all the materials related to deep learning, inferential statistics, descriptive statistics, okay, data structure algorithm, so as the students can get some idea that how to incorporate them in the Pythonic platform. So all the theoretical part as well as the coding part, everything has been given there. So you can check out my GitHub repository. You may follow me there as well. And also finally, also I'm sharing my YouTube channel link as well, where I am gradually uploading all my talks there. So you can take the help from there as well. All of so I am sharing, requesting the all to the organizers to share all those links to the participants, such that they may remain benefited. At the end of the day, the youngsters are the future of this country as well as this globe, across the globe. So you see that The more you will shine, the more you will be able to successfully pursue your career. All the efforts like Shiba and their team are doing through the help of the Scalar Academy, and all the communities also, tech communities are also taking their part to train you guys, to give you some new ideas. Okay, so then all those efforts will remain successful, because at the end of the day, we have to keep it in our mind that these across the globe, there are more than 80% people under the bottom of pyramid category. In before pandemic, it is now more than 85%. In India, it was more than 96%. Now it is more than 99% after pandemic. A lot of people lost their job as well. So you can understand this percentage of the people do not have enough money to pay tax. So whatever may be our profession, we can be scientists, we can be doctors, we can be engineers, we can be teachers or professors. It is our social responsibility to try to contribute something, whatever little knowledge we have, with this kind of the high-tech projects. So if the technology can become the friend of the human being, then the life will be much more smoother and easier. So like we always say, that let us take a vow that let us make the technology as the blessings of our society. Okay, so so let's hope for the best. Stay connected. Okay, stay safe during this pandemic scenario. Thank you very much for inviting me here. Take care.
All
Okay,
right.
thank you.
Yeah, thank you so much, Sabyasachi. I think we covered so many different great things from the entire project and also the topics that you covered about MLP and all other, like, basic concepts about NumPy and everything. So we covered definitely quite a lot in the time
We
that
also
you
incorporated a live project there, that how to download dataset from Kaggle,
yeah,
how to run those codes there, and after getting the outcome, how to upload the dataset in the CSV format to Kaggle. Every details we have covered. So we have not
yeah, yeah.
left out anything actually.
Yeah, yeah. And thank you so much for doing that. I think that we have definitely learned quite a lot, and all the live audience they'll benefit quite a lot from this session. And of course, we have already shared all your details, such as your email, your Medium link, your GitHub, and of course, we'll be also sharing the links of all the notebooks that Sabyasachi has gone over.
I will mail you. I will mail you.
Yeah. So we'll be sharing them shortly. So do stay tuned for that. And if you wish to connect with Sabyasachi, you can connect with him on his email as well. And of course, if you don't mind, Sabyasachi, we would love to have you for some other sessions as well in the
Sure,
future.
sure, sure. Definitely, I would love to
Yeah,
come there. Yes, thank you very much for inviting me
because
here.
yeah,
You
because
guys
like
are
the
doing great job,
hmm,
and as I mentioned, that whatever the little knowledge I will have, I will definitely try to share with all our loved participants, such that if it can help to benefit in their career, then all my efforts will be successful. So thank you very much for inviting me here. Thanks a lot.
yeah, and of course, like as we're just describing that there are a lot of people, like folks from the community who are really passionate about deep learning, about machine learning as well. So, like it's really great that we were able to get this session and right. So yeah, like a lot of people are asking for notes, so we'll be sharing
We will
everything
be sharing.
shortly. Yeah, so we'll be sharing everything on Discord. So yeah, thank you so much, Susachi. I think it was a
Thank you for the
great.
invitation. Thanks a lot.
Yeah, absolutely. Thank you so much.
Thank you. Take care. Bye bye.
Bye.